Hello everyone, welcome back to Everything Swift. Today we are tackling Leetcode question 876 titled Middle of the Linked List. This is an easy level Leetcode question, but I think it's quite important for us to go through this question as it serves as a foundational knowledge for us to understand linked list. And the solution that we're going to do for this question is quite important for us to solve more complex linked list problem. I think I've seen several medium level and hard level linked list question that requires us to perform this solution pattern for as part of the step to solve more complex linked list problem. So it's a extremely important foundational thing in linked list that you guys should be familiar about if you guys want to attempt those medium and harder level problems of linked list, right? So let's go through this question. So basically, what we are given here today is a list node, which is of type singly linked list, right? And we're supposed to return the middle node of that linked list. So what is a singly linked list? So basically, as you can see in this example here, is basically a linked list is containing a chain of list nodes, as we can see in this class here, right? It contains only two properties. In this example, at least, there's a value and next, right? Next is basically a reference to another instance of a list node class, right? So if you can see here, this list node here, this linked list has multiple list nodes. And this list node here, basically the val is 1, and he has a next reference to 2, right, which is another list node. And 2 has a reference to another list node, which is 3. 3 is the val, right? And then next to 4, which is the val, and the next is 5, right? So basically, these are all list node inside, and the combination of all of them is basically the linked list. So we are supposed to find out what is the middle node. So the tricky thing about linked list is that it does not have properties or attributes of count. We are not able to get like, for example, this uh, linked list, right? Like there's no concept of like return count. So for example, like array A, for example, an integer array of 3, 1 to 3, we can get the count number of elements within this array by just accessing the count attribute here, right? The problem is with linked list, we don't have this count attribute. At least in this class problem that we're given, we don't have that concept, right? So imagine this question was asking us to find the middle of the array, for example. We could easily do like getting the count and then divide by 2, and then we get the index of the mid index. At least there's one way to do it, right? So for linked list, we don't have the concept of count, so we can't really find the index. And actually, in linked list, there's no concept of index as well, right? So just to highlight, like it's not really that straightforward, but it's not difficult as well. Once you recognize this pattern, it's actually quite straightforward. So how do we solve this problem, right? So we don't have a count, we don't have concept of index. What do we do, right? So one way to do it is that we can go through, loop through this whole thing and actually get the number of count of nodes and then loop again and we to the middle of the count, right? So for example, 1, 2, 3, 4, 5. So basically we can take like 5 divided by 2 and then loop through to the to that 2 index, and basically you will find your middle node, right? So that's one way to do it, at least I can think on top of my head. But usually what I'll do is, and it's actually quite a popular solution, is to use a slow and fast pointer. This pattern is actually very popular in linked list questions, and I think I would suggest to get familiar with this concept because you can see it in a lot of questions in a more complex problem. So slow and fast pointer essentially means there are two reference to the initial linked list node, right? And what you will do is that the fast pointer will travel 2 times faster than the slower pointer. So for example, slow and fast pointer will start at this node here 1, and then fast pointer will go 2 steps. So next and next. but at the same iteration, slow will only advance once, so one time. So fast is at 3, slow is at 2. And then it goes again, 1, 2, and then 2, the slow pointer will go to 3, right? So we'll keep that same pattern where the fast keeps going twice as fast as compared to the slow pointer until the fast or fast next is actually nil. And with that, we will find that the slow will always end up in the middle of the linked list. So that's how we find the middle point of the linked list using slow and fast. Right? The code is fairly simple, but just to explain, basically we have two pointers, slow and fast. Fast travel two times faster than slow until fast or fast.next is actually nil. And that's about it. That's the solution for this question. Right? So let me jump straight into the code and we can see how this works in action. So as always, you guys know I like to check if head is nil because just for some optimization, if it's nil, then pretty much we can exit out of this function. So it's just a faster, small optimization here. So once we know that it's not nil, we go ahead and set 2 pointers, right? Slow is the head reference and fast is also the head reference. So at the start, they are basically starting at the same exact point. So as I said, fast will go 2 times faster as compared to slow, and we'll keep that loop alive until fast is nil or and fast.next is nil, right? So fast not equals to nil and fast dot next. I'm using a force unwrap here because we already know from the first part that it's not nil. You can also do something like that. Yes. Not nil, right? So this loop will keep going as long as these two condition is fulfilled. So what we're going to do here is slow will go to next, only one step, but fast will go 2 steps. So fast dot next and next again, right? So this is where I kept saying that fast will traverse 2 times faster as compared to slow is because of this, right? Slow only goes 1 time, 1 next, and fast goes 2 next. So it's 2 times faster than slow. So once this operation breaks out, and because this condition is no longer fulfilled, slow is basically the middle pointer. So basically we can go ahead and return slow. And that is about it. That is how we find the middle of the linked list using slow and fast pointer. So let me just go and run it, the code, make sure it's correct. And looks like it does. Let me use more sample tests. Hopefully this is right. This is also right. I'm just going to submit this. And looks good. This is a solution. So yeah, so basically I know it's a very easy problem. It's also a Leetcode easy question, but this pattern here is extremely important for you guys to recognize, to be aware of, to find the middle point. Because there are questions that are more complex in linked list where you're supposed to find the middle point and then break the chain and then reverse certain portions. So those kind of pattern requires this knowledge, this slow and fast pointer usage to find the middle point. So I think it's quite an extremely important question to go through, and hopefully this question is quite useful for you guys to kind of like see how we use 2 pointers and to solve the problem. So as always, thanks for watching the video, and please feel free to subscribe to the channel and share this channel because I'm trying to grow this channel as well. I'll do more questions like this using Swift. So as always, thank you very much. Take care and bye bye.